So section 5.9's a word problem section, and when I glance at it, it feels like the problems that I've written here I lifted from the first chapter or maybe from the third chapter. The words feel so much the same that it doesn't feel like, this is anything new. The new part of this is that when I create an equation to model the word problem, I'm going to get a square in it. And earlier in the semester, we didn't get squares. And let me see if I can read through a problem and walk you through how we're going to solve it. That table we learned from the very first section would be appropriate here. I'm just going to kind of talk through that table because I remember it well enough. But anyways, I start reading the word a number, and generally, when I see a number or the number, I think the x or some variable name. So for a number, I'm going to put x. Generally, when we have the word is, we replace it with an equal. And so that's going to give me the beginning of my equation. And then the rest of my equation is going to come from this part of the sentence that says 12 less than it squared. Less than is a subtraction word, and you switch the order. So we've done this 3 or 4 times this semester. And so I'll start setting up my subtraction. The less is going to be a subtraction. Because this stuff is written after the word is, it's going to go to the right of the equal sign. And what am I switching? I'm switching the 12 with the its square. The its square is the new part. So I'm switching the 12 and something to represent its square. And that's the tricky part, or that's the new part. The its square represents the square of the number. And the its square is going to be whatever number I'm working with an exponent of 2. So I'm switching the 12 and the its square on either side of a subtraction from the word less than. And the its square is going to go preceding the 12. Now I'm just going to solve this. And to solve it, there isn't any factoring to get rid of, but there is a 0 that's needed. So I'm going to set it equal to 0, and 99 times out of 100, when we were doing, I think 100 times out of 100, when we were solving the equations in section 5.8, I had the 0 on the right-hand side. This is going to flip that. Specifically, when I try to get 0 on one side of the equal sign, I'd like the x squared term to have a positive in front of its for its coefficient, and so it's okay to have 0 on the left side. Most of the problems in this section, the algebra will produce 2 solutions, and that's going to be the case here. So need to factor this. Double minus, the signs are plus and minus, smaller number is positive. I'm going to sight factor. Actually spell sight. I'm going to sight factor. I'm going to create 2 parentheses on the right hand side. I'm going to split the x squared evenly and put it up front in the parentheses. And for the minus 12, I'm going to write the factors down: smaller number plus, bigger number minus. And find the pair that add up to -1. And I don't have to do every addition here. And the additions really are subtractions because the numbers have opposite signs. And the reason I'm shooting for a -1 is the middle term has an applied -1 as a coefficient. So the numbers I'm going to use in my parentheses are +3 in a minus 4. Once I get a problem factored and set equal to 0, I can get the answers by setting each factor equal to 0 and then doing the algebra to isolate the x. So I get two different answers. I claim the answers are how about I'll write a little sentence. The numbers are, I don't really need x in my answer. I just made that x up. The numbers are negative 3 and 4. And let me show you that these actually work. I'll show you that the numbers I've created, negative 3, if I can compare negative 3 and the square of negative 3, the square of negative 3 is 9. Is negative 3 12 less than its square? Because this is the number. This is its square. And my number is supposed to be 12 less than its square. So let me see if negative 3 is 12 less than the square of negative 3, which is 9. And it is. Similarly, I look at the number 4 and its square, so the number and its square. And 4 is definitely less than 12 less than its square. 4 is 12 less than the square of 4, because that's 16 minus 4. So I've kind of checked these. Three and 4 are similar to the last problem. Let me see if I can push through this. It says the square of a number. The a number part of this is going to be the x, or what I'm going to define as x. But a square of a number I'm going to write as x squared. So as I read through problem 4, first I see the square of a number, which I write as x, and then the is going to give me an equal sign, and then after the equal sign, 12 more than a number. More is a word that leads to an addition, and just like less, it's a switching order. So I'm going to create a plus sign for the more, and I'm going to switch the order of 12 and the number. The 12 is going to go after the sign, or the plus sign, and what I represent for a number, which is x, is going to go before the sign. So just a little short sentence that transforms into a problem with an equal sign. And I'm going to solve it exactly the same way, other than I'm going to get the 0 on the normal side. Because when I get this equal to 0 so I can solve by factoring, I have a strong preference that the x squared term stay positive. And so for this problem, to get it set up to factor, I'm going to minus x and minus 12 from both sides to get the 0 that I need. And we get the 0 on the right side. I'm going to write the left side in a normal order. And is this exactly the same factoring? If it is, I don't have to think very hard. It's exactly the same factoring. So I'm just going to leave it. I'll steal the factoring from problem 2 just to save a minute. It would be exactly the same steps. The factor of x plus 3 gives a number answer of negative 3. The factor of x minus 4 gives an answer of 4. And so I get the same number answers. The answers are, the numbers are, don't really need an x. If you wrote an x, it's not wrong. It's just that the problem didn't have that x. I just decided on that x. And let me just check real quickly to make sure if I go to this problem, if I plug in -3 for x, that I get a true statement. And if I plug in 4 for x, that I get a true statement. I don't really need to push through the logic. If my equation is right, then just checking the algebra will be sufficient. So if I plug -3 in for x into this equation and square it, which means I need the -3 in a parentheses to not choke on my sign. -3 squared is +9, and then -3 plus 12 is also +9. -3 checks. When I do this side, checking the 4, 4 squared is 16, 4 plus 12 is 16, so it checks just fine. So the only thing new verbally is the word a square, which means I need an exponent of 2, and then everything else is kind of the same. Something that we did, I think in chapter 4 we talked about consecutive numbers. Actually, we talked about consecutive integers, and the answers here are going to be integers. I could have written problem 6 as the product of 2 consecutive integers. Probably would have been written better, but truly doesn't matter. But maybe to be consistent with what we did in chapter 4, I'll go and change these problems to say integers. And we have to remember that in chapter 4, we had consecutive integers, and we had like consecutive odd and consecutive even integers. In the world of these kinds of word problems, remember that when we had consecutive integers, the first number was x, the second was x plus 1, the third was x plus 2. I just keep adding 1 because these are directly next to each other. We also did consecutive even integers back in, I believe it was chapter 4. And we did consecutive odd integers. And we had a way to define the numbers. The first number was x, the second number was x plus 2, the third number was x plus 4. And it didn't matter if they were consecutive odd or consecutive even integers, they were defined the same way. That we need to remember. This is the evil thing as you get higher in math. You need to remember some stuff that may seem insignificant at the time, and this we need to remember for the next few problems. So in problem 5 and 6, the product, which means multiply, 2 consecutive integers is 20. So this whole part of the sentence, I need to create variables and create the left-hand side of the equation, because directly after it I see is 20, and that's equals 20. So I need to create the left-hand side of the equation from that sentence, and I need to define my variables. I'm looking for 2 numbers. I'm going to call the first number x, the second number, which is going to be the larger number, x plus 1. And now I'm going to do the product. I'm going to multiply those numbers. So I'm going to do the product of x and x plus 1. Those are the variable names for the consecutive integers. That's what that part of the sentence gives me, and then equals 20. I'm going to solve it by clearing the parentheses. I'm going to multiply x times x and get x squared. I'm going to multiply x times 1 and get 1x. I don't really need to write the 1, but it's fine to write it. And then equals 20. I'm going to set it equal to 0. And I'm going to solve by factoring. This is the third row of my template. I'm going to cite factor because there's not a number in front of the squared term. And for the negative 20, I need to break it up into numbers that are one positive and one negative, bigger number positive, smaller number negative. So the factors of 20 that fit what my chart would ask that I would need are 20 and negative 1, 10 and negative 2, 5 and negative 4. I need the pair that when I add the numbers, I get 1. So the numbers I'm going to need for my parentheses are 5 and negative 4. And now I'm just going to say when I set x plus 5 equal to 0, that would give me a solution of negative 5. If I set x minus 4 equal to 0, that would give me a solution of 4. So I'm going to say the numbers are negative 5 and 4. I should check just because it's I didn't do so well in my answering. I should pair up my numbers because I need consecutive integers, and first number is x, second number is 1 bigger than x. So the number should come in pairs. So the answers come in pairs. Let me do the baby one first. For the number 4, I'm going to say the smaller number is 4. And the larger number is 5. Those are consecutive integers. 4 and 5 are consecutive integers, and their product is 20. So one set of consecutive integers, smaller number, positive number, but consecutive integers whose product is 4 and 5. And I got that by using the little chart that I have here. I let the first number be x and the second number be x plus 1. So 4 and 5 are consecutive integers, their product is 20. And then let me get the other set. The other set algebraically, I got negative 5 for the first number, and then I do negative 5 plus 1, and negative 5 plus 1 is negative 4. So the other set of numbers that are going to work is the smaller number is negative 5, and the larger number is negative 4. Those are consecutive integers. There's not an integer between those. And when I multiply negative 5 and negative 4, I get the required result that the product is 20. So there are actually pairs of answers because I'm looking for two numbers as opposed to one number.